Hello? Yes? Okay, let's get started. I think this one is the LAB5, so less people will come. That's pretty normal. Most of people will just have a look of the recording. Okay, let's have a look what we have today. So we will review the TCP congestion control at first because we'll need to have a look of it to do the LAB5. So we will have a look over the slides and review all the contents, all the key concepts on this part. And then we can do the LAB5. We will spend like 10 or 20 minutes to have a look of it. So the slides is this one, the week 5 transport layer part 2. We'll copy the link to the chat. So we start from page 84. Please open the page 84, but yeah, if you don't have your computer for now, if you are using your mobile phone, that's okay. I put the slides into this PowerPoint. So in here, we will need to know what is the TCP congestion control. Why should we use that? And what is RTT and Cwnd? What is slow start and AIMD? And the TCP flavor, Tahoe and Reno. So if you find any keywords here you are not familiar with, so you should pay attention to it because they are pretty important for this lab, and especially for these two, Tahoe and Reno. I think they will test this kind of stuff in the final exam. So yeah, this part is pretty important. So let's see what is TCP congestion control. Why should we use it? Have a look of the slides here. So you can see this chat. In the x-axis is the load of the internet, because let's say we will have a bandwidth to our internet, let's say 100 Mbps. So our computer does not know what is the limit of our bandwidth. So we will try to utilize our bandwidth to utilize the speed. But how can we achieve this? We want to maintain at this point, right? But we don't want to have too much load, which may lead the congestion happened, and then it will reduce the speed significantly. So how can we find this point and do not exceed this point? So that's the key problem for the congestion control. And the second graph here, with more load, the delay will increase significantly. So we don't want to have too much delay like in here. So we want to keep the balance of the load and the speed. So that's the reason why we need to do the congestion control. So let's see, how can we do it? The first concept is the Cwnd, congestion window size. So in here, we set the CWND in the unit of byte instead of the packet number. We will have a look at it later. But yeah, you only need to know is CWND, which means congestion window, and RWND, which means the receive window here. So in sender side is basically depends on CWND, and sometimes will depend on the RWND, but the receive window will like greater than the CWND normally. Okay. And yeah, just make sure you understand what is CWND, and remember the unit of CWND is in byte here. And the CWND is always in units of MSS. What does this mean? Which means it always a multiple time of the MSS. Do you still remember the MSS? It's maximum segment size. If you can recall the LAB4, we have a part of it, right? This, let me try to open LAB4. Can you see the window size here? So this one, we can, let's think about it, is CWND. And the length of the packet, like in here, you can see what is the length of a packet, and can we find the maximum number? Oh, I think it's this number. The maximum number of the length of packet is 1514, right? So that's the maximum packet size, and that is the maximum segment size here. We call it MSS. So in here, what does this mean? It says that this window size number is always like the multiple times of the packet size. This makes sense? Can not the average, the maximum segment size. Don't worry too much about this point. We will not test this part. Just make sure you know the CWND is like a Windows, like a limitation of the speed. So we will use the CWND to control the speed of like sending rate or receiving rate. And the unit is in bytes. So that's the first key point that we need to know, CWND. And yeah, the second one is the recall of the fast retransmit. So if you still remember, how can we like do the fast retransmission? It's like this. When we receive 3 duplicate ARC number in here, acknowledgement number here. Here you can see acknowledgement number 3 duplicate, and then we will resend the packet we lost in here. Can you see that? Because we send 1, 2, 3, 4, 5 packets in this at the first time, and the second packet is lost or damaged in the middle, so it didn't receive the another side. And the fast retransmit will not wait for it, because the other packet has been received from the host B, right, in here. This part, and this part. But they can see the sequence number is not 100, and the host B will know the second packet is lost in the middle, right? So it will apply the ACK number of 100 because we need to get the second packet at first, and then we can build the file. So it will reply the ACK number in like this to indicate we need the second packet. So the host A will resend the second packet in this way. So that's fast retransmit. But if the host A does not have this fast retransmit, it will wait for the timeout of the second packet. Right? But with this function, we don't need to wait for the timeout. So that's the reason why we call it fast. It can save some time. So we don't need to wait too long for that. Okay, is that okay? I think this part should be easy. So the next one. The slow start. The slow start is another key point for this congestion control. It's really important. And let's see how it works. What is slow start? Because we want to find the like maximum speed we can maintain for our computer, right? We want to send as much as possible at the same time, but we don't want the traffic be congested. So how can we find the maximum number of the speed? So the first strategy, let's call it slow start. And we use it for the bandwidth discovery. So use this method to discover what is the maximum bandwidth we have. And yeah, the principle is pretty easy. Basically, at first, we will send only one packet to the other side. And if we receive an acknowledgement here, which means we send it successfully, then we duplicate the size of the packet we have. And this time we send 2 segments here. And they reach another side and receive an acknowledgement here. Then we can send 4 at this time. So it was 1, 2, 4, 8, like this. So we keep sending, keep like multiple the size of the packet every time if we can receive the acknowledgement here. So there's no congestion event here, right? No packet loss and no delay here, and no timeout. So with the slow start, it will be looks like this. This part, you can see the window size increasing this shape in a curve. Then we can know this part is slow start. But how about this part? We can see it's increasing like in a linear way. So what is this part? We call it AIMD. So the A is stand for, I think it's additive here, additive increase. And the M stand for multiplicative decrease here. So the AIMD is another strategy to maintain the high speed of our internet. Because at the first stage, we may use the slow start to find the maximum speed of our internet, and then after that point, we will use a strategy called AIMD to maintain a stable, probably not very stable, to maintain a very high speed as possible, like this. So how it works, it will increase the Cwnd by 1 MSS, which means 1 packet every RTT until the loss detected. So what is loss detected? Like the loss in here. What is loss? The packet loss, right? So it could be a packet loss. So what kind of packet loss we may have? The first one should be the fast retransmit, right? We lost a kind of, we lost the packet. It can indicate it by the fast retransmit. And the second one could be the timeout, right? In here, the loss detected only suitable for the packet loss, but when we reach a timeout event, we will go back to 1 in here, and we will talk about it later. But in here, you know, the AIND, which means we increase the packet size, the CWND size by 1 each time, and we decrease it by this method, divide by 2. So that's why we call it AIMD. So in here, we know what is AIMD and slow start. So we need to use a way to combine them together. Okay, because these two strategies have their own like advantage and disadvantage. In here, let's have a look of the slow start again. The slow start, you can see the increased speed is faster, right? Because it will multiply by 2 every time. So the increased speed is very fast. So it is very good at the beginning of the like TCP connection. But why don't we use it all the time instead of we want to combine these two together? Like here, you can see with the AIND method, it increase 1 at a time, right? So it increase slower. So I think there are 2 reasons. First one is we don't want to reach this point too often to reach the loss point events too often. If we keep multiple by 2, multiple the packet number by 2, we will always reach the loss event. So that's the first reason. And the second reason is for the TCP fairness. So we will have a look in the exercise 2. Because if we keep doing the slow start, the other computer will very hard to get enough speed to build a TCP connection once we have already established a TCP connection. So that's the reason. Anyway, we want to combine these two methods. The first one is slow start, and the second one is AMD together to build a better algorithm, to better way to avoid the congestion. So how can we do it? Now in here we introduce the first TCP congestion avoidance method. Let's call it Reno. So it combined with 2 stuff. In the first stage, we use the slow start in here, in this part. And it will reach a stuff, and we call it SSTH. So it's slow start threshold. We will set a number for this value. So once we reach this point, we will change our strategy to AIMD. And then we keep going. Like in here, we find a congestion event. It's called fast retransmit, which means we lost the packet, right? So we just divide our Cwnd by 2 and come to this point and keep using the AIMD. And once we receive we find the retransmit or packet loss, we will divide our speed by 2. So that's how it works. And if we find a timeout event, which means the packet is timeout, we will go back to 1. This part is 1 here and start from low start. So that's how Reno works. So you can see it's a kind of strategy how we use slow start and AIMD, right? So don't worry too much if you don't understand how it works. We will have a look of it later. Sorry. Then let's have a look of another strategy, which is Tahoe. Tahoe is here. So what is Tahoe? This part is a slow start, right? And we come to the SS threshold here. And then we start to use the AIMD. And once we find a packet loss or a timeout event, then we just come back to 1 here and start again. Does this make sense? So the Tahoe is the simplest method we use, and the Reno is a little bit complicated. And let's have a look of the algorithm of it. So the Tahoe, we will set the Cwnd equal to 1 if we find any congestion event, no matter the fast retransmit or timeout, we will back to the window size to 1. And the Reno, it really depends. If timeout happened, we will go back to 1 and start from 1. But if it just a packet lost, we will divide our window size by 2. So as you can see here, for the Reno, probably it can reach back to the fastest speed than Tahoe, right? So that's the 2 strategy we use to control our the speed of our computer, the Tahoe and Reno. I think here we don't need to know what is new Reno or TCP/SAC. We still have other strategy to make it better. But yeah, in here all we need to know is Tahoe and Reno. Oh yeah, probably I should have a look of the SS threshold. This one, because we want to fuse the slow start and AIMD together, right? So in here we introduce a value called slow start threshold, SSTHRESH, this one. So what is this stuff? This stuff is it's like a value. When we reach this value, we will switch our strategy from slow start to AIMD. As you can see here, this value is in here. Let's say it's 10. So we will set this value as 10. And once we reach this speed, then we will switch our speed from our method from slow start to AIMD. And this value is not a fixed value. Once we a congestion event happened, we will reset this value by divide the number of it to like in here. So in here, the fast retransmit happened. So we will reset the value of it to this number. Does this make sense? So that's the reason why you can see they are in two different points here, right? Because this value is calculated from this value. So the slow start threshold is always depends on the last congestion event, like this one. It could be a timeout and it could be a fast retransmit. Okay, so and in here you can see the slow start threshold is set, let's say 16, right, at the first stage. And then a congestion event happened in 20 here. So we will set the slow start threshold as 10 in here, 10 in here, right? So you can see that's how it works. We restart from 1 and increase into here. Then we reach this number. Then we switch the slow start to AIMD. So yeah, so that's how it works. Yeah, it's my bad. I didn't introduce this one properly. Yeah, it's a little bit complex, but once you do the calculation of it, it will be clear. So anyway, let's have a look of the lab. So that's all we need to know, I think. Let's back to the first page. What and why, and what is RTT, and what is Cwnd. So this one is really important. Cwnd is the fundamental stuff for the congestion control. And what is slow start? This one is very important because every strategy, including Tahoe and Reno, will use it. And what is AIMD? What is Stanford, right? And what is the difference for Tahoe and Reno here? So that's all we should know. So if you cannot remember what is the difference of it, jump to this page. You can see the difference is in here. So when the timeout or the other stuff, congestion event happened, what should they do? That's the only difference. For the Tahoe, we always back to 1, no matter we lost a packet or timeout. But for the Reno, we only back to 1 when a timeout happened. But if we lost a packet, we just divide the congestion window by 2 instead of go back to 1. That's the difference. You need to remember the difference of it because we will always test it. Yes, Reno can probably send more packets. Yeah, you can say the Reno have like higher efficiency, but we can't say Reno is always better than Tahoe. It really depends on the environment of the traffic. If the like the connection is not really stable, I think sometimes the Tahoe is better than Reno. That's all for the congestion control. Let's have a look of the LAB5. Have a look of this part. So in here, we can know. So what happened in here and in here? What happened in one? We lost the packet, right? Why we like come to here instead of come to here? And obviously it is a renal, right? Because if we are using table, we will always back to one. So in here, we come to the halfway, right? So it must be a renal. So in here, it's asking packet loss here. And in point 2, it's a timeout event here, right? And we back to 1. So that's the first thing you need to know. This is the second question. What phase of the congestion control marked by 3? Yeah, it is asking this part. How could we call this phase? Yeah, it is slow start. All right. And we call this phase is the bandwidth detection or something. Back to the slides, have a look of it. How can we call it? Yeah, bandwidth discovery. But you can say it's a slow start. That should be okay. Now, what is this part? This part, the fourth, number 4 here. So this part is obviously the other stuff, right? AIMD. So I think that should be enough for the first one. And why this window increase more rapidly at 3 than at 4? So we need to explain the difference of AIMD and slow start. The way how they change the Cwnd, right? In slow start, we multiplied it by 2, and in AIMD, we just add it by 1. And can you precisely explain what happened to the window after 2? So what happened if we find a packet timeout event? After here, it is a packet timeout. Yeah, it should go to 1. So the first stage is we go to the first step is go back to 1, right? And what is the second stuff? The second stuff, we slow start, right? But yeah, between 1 and 2, actually there's another thing happened, is recalculate. Recalculate which stuff? Yeah, the slow start threshold, right? The the threshold should equal to the Cwnd divided by 2, but I'm not writing here, but you should know that. And the third one is reached. So that's all we happened here. So that's how it works. Once you can understand all the stuff here, this part should be easy for you, and you should get all the marks in final exam for the congestion control. They will always ask you, how can we do the calculation of the slow start, and what is the difference between it, and can you recognize it's a renal or tail through this kind of graph, right? So they will always ask you about the difference of it. So that's all we should know. And we can come to the exercise 1. Just be aware, this part we don't need to submit into your report. Just have a look of it to make sure you understand all the concepts. And we start from exercise 1. So this part actually is pretty easy. We don't need to do any coding or other stuff. All we need to do is run the code. And we don't even need to have a look of this kind of code. Just simply run the code in here, this one and this one. But before you run the code, make sure you download the stuff we need, which is in here. Download the stuff. ep window.tcl should be somewhere here. Just click this link and download it into the LAB, because we are going to run it in the LAB. And then download another stuff called window.plot. It's in here. Just click the link and download it like this. And then the stuff here, window t throughput.plot. Yeah, just simply download it. We don't need to do any modification of it. And yeah, let's have a look of how we use it. Here. So firstly, just download it and open the folder. So I download all the file in this lab, and I just run it like in here. The first command we need to run is this one. And we go to the download file, right click, open terminal here, and paste the command and run it. Yeah, and yeah, finished. And run the second command in here, back to the terminal here, and paste the stuff and run it. Then you can see the outputs of it. So let's have a look. What is this kind of stuff? It's just the similar stuff, right? If you can understand what have we learned before, then you should know what is this picture. In here, obviously, probably not very obviously, it's tail. So what happened in here? You can see we at first use slow start and reach here, and we back to 1 because probably they may have a congestion event like timeout or packet loss, and we back to here. And then once we reach around 50, we start to use AIMD here. This part, right? It's around 50. So how can we get this number? This is because we have a congestion event at 100, right? So that's the reason why we switch to AIMD here. And at this point, we had a congestion event again. Then we back to 1 and back to slow start and switch to AIMD and again and again. Yeah. So that's what happened in this graph. And you can see the command we set, because we run this command at first, right? This command. So what does this 150 means? It's max initial window size. Actually, I think it's a Cwnd. So we at first set the Cwnd at 150 at here. But you can see the maximum number is 100 in this graph. So we didn't reach that number, and then a congestion event happened. Could be a packet loss or timeout at this point, but we didn't reach the value of 150, right? And we reset it as 50 since we met a congestion event. So that's all happened here. So you are required to answer all the questions here because we have already explained. I'm not going to answer it one by one. But if you do have any question for the question here, just let me know. And for the question 2 here, simply download the stuff, window tput.plot, and run this stuff in your terminal. Then you will see something like this and explain it. The throughput, the speed. You can see with the Tahoe method, we can maintain our internet speed at the average level of this part here, sorry. At around 190 or something. You need to have a look of the number of the file by clicking it. And yeah, just discover this part. And for the question 3, just rerun the script, but you need to change number in here. So just copy this one and run with other value of it. Let's say 100, or you need to run it again and again to see what is the output of it. In here, I just show an example of it. then you can see the difference of every graph. So you just run it with different value in here for this command. So you can change this number to other value you want. You need to try the number and find the value of maximum congestion window. So yeah, just discover by yourself and let me know if you have any doubt. You can change this number, see what is the difference of it. Like this. Yep. You can see what is the difference for the value of it. Okay. And in here, question 4 here, we are required to change the code a little bit. For this part, you need to modify the file we have in here. So just open the stuff. What is the name of the file? The name of the file should be the tpwindow.tcl. So we just find the file in here. The name again, window. Yeah, it's in here. So I open it. It asks us to change the stuff in here. So we just searched for this line. This line, right? We need to change it to this stuff. So basically we are switching from Tahoe to Reno. So we just change the code here. We just paste it. And we are using Reno now. And then we can rerun the stuff we have. So I close it and rerun the scripts we have. Exactly the same, just copy and paste and draw the graph. And you can see it's different in here, right? Because the previous stuff, when we use Tahoe, we will go back to 1 at this stage, right? But in here, we just divide it by 2. So that's what happened. Then you just change the code and answer the question 1 and question 2 again. And that's the question 4. So do you have any question for the exercise 1? Should be pretty easy. Why did it take so long to have congestion event? The first time while all the time similar time. Let me check. I think it's quite similar. Are you talking about this one or the other stuff? Because in this script, the very beginning one with 100, yeah, I remember that one. Because it's a script. So this script, so this plot it's running on the simulator. So we have set some logic behind it. You can have a look of the TP window here, this file. You can have a look of the logic of it. It is some code. You can see what is the logic of it, how many nodes we have. We have 2 nodes and a link between them, and the speed is 1 Mbps. And it has set some logic after for this kind of congestion event. Probably it's a random event or something like that. You can have a look of it, how they said, how they let the congestion event happen. I didn't see, I didn't see it, but you can probably find it in this file. Yeah, the max window size is, I think you are talking about the exercise 1, question 1, right? Yeah, you're right. Okay, so let's get back to the exercise 2. The same stuff in exercise 2. Simply download the file by click the link here and run it. In here we just open the terminal and paste the command and run it. And then run the second line, and the same, we need to download this as first and run it. Paste it, and then you will see something like this. And in here we will discover why should we use AIMD but not use the slow start all the time. So if we use slow start all the time, you can see the flow 2 to 3, which means it is from the node 2 to node 3. They established a TCP connection at the very beginning, so they can utilize the bandwidth because they are the only 2 computers using the bandwidth. And once the other flow join to the traffic, like flow 4 to 5, 6 to 7, the speed will decrease by divided by 2, right? It dropped from around 120 to around 60. So if we are not using the AIMD method, if we only divide by 1 or something like that, the other computer will not get enough bandwidth, and we cannot achieve the bandwidth fairness like this. So that's the reason we want to use AIMD, because it can make sure every computer may have the chance, the fair speed. So if we keep using the slow start, this thing may not looks like this, right? Because the flow 2 to 3 is always have all the bandwidth here. And if they are all using the bandwidth, either the flow 2 to 3 will use most of the bandwidth, or the internet will be congested, so everyone will get packet loss instead of sending the packet to other site. Just simply run the command and answer the question here. So why can they achieve the TCP fair? Something like that should be an easy mark for you. So if we have any trouble with this part, yeah, just remember to include the plot we generate, which is this one. Where's my plot? Yeah, but remember to put the plots into your report and answer the question. And exercise 3. TCP competing with UDP. I'm not sure if you are, have you ever used the P2P stuff or torrent stuff or any download software before? So if you had used that kind of stuff before, and if your home have a very limited bandwidth, then you may find if someone is downloading the stuff and we can't even open a video or even open a web page. So that's what we want to discover here. So once the TCP encounter UDP, what will happen? Just simply download the script in the exercise here. There are two scripts here. Just download it, and yeah, the same thing. Just copy the stuff and run it. Link capacity. I think in here, yeah, we need to change the link capacity to 4 Mbps. No, oh, it says I don't have this file. And I need to find the file here. Okay. Nope. And let's see if we can run the stuff. Yeah. So run this command, but it has some wrong stuff here. You can see if we copy it and then we can't run it like this. The first thing you need to take care is the file name. It is wrong in the lab. You just need to change it to the right name of it. So NS, which means we are running the simulator. And the file name is tp-tcp-udp.tcl. You can see the .tcl is missing here. We just put it in our command line. And plus a link capacity. I'm not sure what kind of capacity in question 1 here. Probably it's 4 Mbps here, but you need to have a careful look of it. In here, I just put it 4 Mbps. And then it will pop out a network simulator. Then we just close it. And then we plot the stuff. And we can find this graph. So what does this graph mean? The blue line is the TCP connection. The red line is the UDP connection. And what is the x-axis is the time. The y-axis is the throughput, which means the speed of it, right? So you can see the speed of TCP link is really poor. And at the end, it doesn't even have any speed. And the UDP speed, yeah, it's very fast, right? So when the TCP and UDP compete with each other, you can see the UDP speed will overwhelm the TCP, which means the TCP cannot get any speed at the end. And that's the reason why someone is download something, then you probably find you will find it hard to download or open a web page when somebody else is downloading a movie or other stuff. Because probably they are using the UDP connection to download the stuff. But you are using the TCP connection to open the web page. So that's the question 1 here. Question 2, you can answer by yourself. Just explain. And question 3, yeah, it's just some very easy question. Then you can answer it by yourself. Should be pretty easy. And here we are required to run it, or run this one. Sorry, that's my bad. Yeah, but basically it's the same stuff. It will pop out the window, just close it, and then run the plot command here. You can see like this. So for 4 Mbps and 5 Mbps, it's a little bit different, but yeah, the idea is the same. You can see the TCP connection. The speed is really poor compared to the UDP because they are competing with each other. And the UDP connection is dominant. Yeah, that's all we want to show you for this 3 exercise. I think most of them are very simple to answer. Just make sure you can understand all the concepts in congestion control here. So let me know if you have any doubt. And yeah, just make sure you understand all the keywords here. I should stop the recording because we don't have any other stuff here. But if you have any question, just let me know. I will stay here until the end.